I want you to picture this. It's roughly 200,000 years ago. You're a human, not a king, not a farmer, just an everyday Homo sapiens standing somewhere in East Africa. You're basically just wondering where your next meal is coming from and, really hoping nothing with bigger teeth finds you first. This is our shared starting line as a species. We were all just trying to survive this incredibly intense environment.
Now, if you could somehow pull out a camera, snap a selfie back then, and compare it to the 8 billion people alive today, one thing would immediately jump out. You almost certainly wouldn't be white, you wouldn't be Asian, and you definitely, absolutely wouldn't be a redhead arguing with the sun every July. All the evolutionary evidence points to one undeniable reality. The very first modern humans had dark skin, for sure.
Which naturally brings us to a surprisingly deep question. If literally every single one of our early ancestors started out with dark skin, where on Earth did all the other colors come from? In this explainer, we're going to dive into how different human populations evolved completely different genetic solutions to the exact same environmental puzzle.
Section 1. The original human color. A shared beginning.
Here's something a lot of people just don't realize. For almost 90% of human history, everyone lived in Africa. And Africa has an almost ridiculous amount of intense sunlight, the kind of sunlight that can quietly destroy your DNA if you're out in it for thousands of generations. And this is exactly why melanin is so absolutely crucial. Melanin gives skin its darker color, but biologically, it's basically nature's built-in sunscreen. It absorbs harmful ultraviolet radiation before it can damage your cells. But more importantly, it protects your body's folate. Folate is this essential vitamin you absolutely need for healthy fetal development and reproduction. So in equatorial Africa, having lots of melanin was a massive evolutionary superpower.
Because, let's be real, evolution doesn't care about aesthetics. It has exactly one goal, one single metric for success. Did you survive long enough to have kids? That's the whole shebang. Generation after generation, individuals with darker skin were better protected from UV damage. They protected their folate, and they thrived. For hundreds of thousands of years, dark skin was humanity's greatest biological asset.
Section 2. The Great Migration Problem. Leaving Africa.
So everything's going great, but then humans started moving. And this is where the story gets kind of wild. Groups of humans began wandering out of Africa. No maps, no compasses, and definitely no GPS recalculating their route. By about 80,000 years ago, they had left Africa. 60,000 years ago, they're hanging out in the Middle East. By 40,000 years ago, they're pushing deep into Europe and Asia. And eventually, around 15,000 years ago, they decide crossing into the Americas is a solid plan. But as they moved further and further from the equator, the environment fundamentally changed. The ultraviolet radiation became significantly weaker.
Now, less UV damage sounds like a total win, right? Problem solved. Well, actually, scratch that. It wasn't a win at all. You see, the exact same sunlight that damages your skin is also required by your body to produce vitamin D. Without enough vitamin D, your bones get weak, your immune system crashes, and surviving becomes really tough. It became a crazy biological seesaw. That amazing melanin that perfectly protected your folate down in Africa, it was now blocking too much sunlight in the north, completely starving you of vitamin D. The very trait that kept our ancestors alive was suddenly a massive liability.
Section 3. Evolving lighter skin. Adapting to the north.
You can maybe scrape by with low vitamin D, but evolution rewards the populations that thrive. So, in these low sunlight regions, natural selection began heavily favoring individuals with lighter skin, who could absorb more of that weak sunlight. And this wasn't overnight. It took thousands and thousands of years. Take Europe, for example. Get this, the first modern humans to enter Europe, they actually still had pretty dark skin. Ancient DNA shows us that some hunter-gatherers living in Europe had dark skin paired with bright blue eyes. It sounds like someone randomized a character creator in a video game. Pale skin only became widespread way later, driven by the shift to farming and changing diets, all just to maximize that crucial vitamin D production.
And this perfectly highlights how creative nature can be. Think of it like two different students taking the exact same math test. They both get the right answer, but they use completely different formulas to get there. That is exactly what happened with Europeans and East Asians. Both groups evolved lighter skin to solve the exact same low sunlight problem, but they used entirely different genetic pathways to do it. They independently hacked their own biology. Same destination, totally different evolutionary road.
Section 4. The human pigmentation spectrum. A continuous gradient. But it wasn't just a simple split between north and south. As humans kept spreading, they encountered all sorts of local environments.
which completely dismantles a really popular myth. In everyday conversation, we tend to lump people into neat little boxes, right? Black, white, Asian. It's clean, it's simple. But biologically speaking, it is completely 100% wrong.
Human pigmentation isn't a set of neat boxes. It's a massive, beautiful, continuous spectrum. North Africans developed entirely different pigmentation patterns than West Africans. Middle Eastern populations adapted differently than Europeans. South Asians evolved distinct traits from East Asians. Indigenous Australians went down their own unique evolutionary path, and Native Americans inherited traits from ancestors who migrated through Asia. Humanity didn't just split into three colors. We diversified, messily and continuously, into hundreds, maybe thousands of shades, all perfectly tuned to our highly localized environments.
Section 5. The Grand Race Illusion, Underneath the Surface.
So, what does this all mean? Well, underneath these surface-level adaptations, which, remember, are just variations in melanin driven by sunlight, our genetics tell a staggering story of unity. If you trace your family tree back far enough, every single human alive today merges back into the exact same African populations. The blonde Scandinavian, the Peruvian farmer, the Korean engineer, if you go back far enough, all our different branches become the exact same trunk.
To put that into perspective, humanity spent roughly 90% of its entire existence looking relatively similar, surviving together in Africa. The visible physical differences we fixate on so much today, they represent a tiny 10% sliver of our history. These changes are incredibly recent. In evolutionary time, it's literally just a blink of an eye. Genetically, we are basically identical.
Inside that early human standing on the African savanna 200,000 years ago existed the genetic potential for every face, every nation, every person you will ever meet. The real takeaway from this explainer isn't that human pigmentation makes us different. It's that we are different in such a highly predictable, beautifully logical way. A little more sun here, a little less sun there. We never became separate species. We are one species, with one African origin that just happened to walk into different worlds.
Every single skin tone on Earth today is just a continuation of that exact same journey that started under the African sun. So, the next time you look in the mirror, ask yourself, how does it feel to see one small, brilliant variation of a 200,000-year-old experiment looking back at you?